So hello everyone. So today we are going to build an intuitive sense of Gauss law in physics, right? So essentially what we are going to do is we are going to do a quick review of Gauss law, and then we will build an intuition for it. So these are the two things which we are going to do in this video, right? So let's just come to the first part, which is the quick review part. So what we did in the first chapter in physics, that if you take an area so here is an area A, and if you pass electric field through it, so here is these are electric field lines which are coming straight towards this area. So this is electric field lines, and here is the area vector. So this is area vector, right? So as per the flux of this electric field, the flux is defined as E dot A, right? So here you have an area with an electric field coming. Here is the electric field. Here you have the area, and the flux through this area of the electric field is given by E dot A. So this is nothing but electric flux. All right. So what Gauss law says is, that if you have any closed surface area and you have a charge inside it which is charge enclosed, right? And because of this charge you have electric field coming out in various directions of various strengths. And what Gauss law says is, if you are going to take this flux of electric field through the surface area and sum it over this closed surface, what you are going to get is Q enclosed upon epsilon naught, right? So it is basically the net charge enclosed. So this is nothing but the net charge enclosed divided by epsilon naught, right? So this essentially is what is Gauss law. Okay. So what we are going to do is, we are going to go ahead and we are going to see an animation and to understand how these electric fields look like when this charge is placed inside this closed surface or when the charge is placed outside the closed surface, and see how it works. Okay. So let's just quickly go ahead and see how it works. Okay, so here we are. So what we see in green lines is nothing but electric fields. So these green lines you see here in the diagram is electric fields. Okay, and what you see here, this surface is the closed surface. Okay, so essentially you have surface 1, okay, which is the top surface. Okay, so you have the top surface, you have the left surface, you have the right surface, and you have the bottom surface. Okay, and the electric field is coming out from the top, from the left, from the bottom, from the right. And whenever electric field comes out through a surface, you have flux attached to it, right? So here is the flux from the top part. Here is the flux from the left part. Here is the flux from the bottom part. And here is the flux from the right part. Okay, and what you see here, lambda this thing here is lambda, right? So lambda 1 is nothing but our charge. Okay, so what I'm going to I'm going to go ahead, and what I'm going to do is I'm going to catch hold of this lambda and I'm going to move it around. Okay, so as I'm moving it around, what you see here is a dance of electric field from the surface, right? So as I'm moving this charge around, the electric field changes. All these points which are closer to the charge have stronger electric field. Anything which is further from that charge has weaker electric field, right? And what you see is the flux through various surfaces is constantly changing. Okay. Okay. So essentially what is happening is, you see there is some electric field which is coming out from the top, so there is some flux, okay, and there is some electric field which is coming out from the left, so there is some flux from the left side. There is some electric field which is coming out from the bottom, there is some flux from the bottom, and there is some electric field which is coming out from the right, so we have flux from the right. Okay. Now, next thing I'm going to do is, I'm going to catch hold of this lambda again, and I'm going to take this out of this box. And then what you see here is there is some flux which is coming out from the top, there is flux which is coming out from the right, there is flux which is coming out from the bottom, but there is a flux which is going in from left. Okay, and that is the interesting point. Okay, now if I'm going to go ahead to add all of them, what essentially I get is 0, right? So coming back, I'm going to add flux from the top and flux from the bottom, the flux from the left, and the flux from the right, and I get the total flux, right? And this total flux should be equal to the charge enclosed divided by epsilon naught. And if that charge is outside the surface area, then there is no charge enclosed, so this essentially turns out to be 0 divided by epsilon naught, which implies the overall flux is 0.